Good day, favorites. Welcome back to another episode of your favorite tutor. And today is your favorite tutor on physics. Okay, today's topic is quantities and units. It's a major topic in as much as the subject physics is concerned. Quantities. Quantity. A quantity is a property of a body or substance that can be measured. For example, length, area, time, volume, etc., etc., etc. So these are what quantities. All right, let's move to units. A unit is a yardstick in which a quantity is being measured. For example, length. Length can be measured in millimeter, centimeter, kilometer, and so on and so forth. That's for what? Unit is a yardstick in which a quantity is being what? Measured. Now, these quantities and units, they are divided into two parts. They have two branches. We have the fundamental quantities and units, and we have the derived quantities and units. Fundamental quantities and units. What are the fundamental quantities and units? I have a table on the board. It shows some fundamental quantities and their what? Units. All right. Length. The first one here is what? Length. Length is a fundamental quantity. And the unit of length is what? Meter. Sorry, the what? The SI what? Unit. SI. By SI, I mean System International. It's a standard unit. An international standard unit recognized by what? Scientists. So the standard unit for what? Meter, for length is what? Meter. You know before, that I told you guys that length can be measured in centimeter, kilometer, and so on and so forth. But the standard unit recognized internationally by scientists is what? Meter. And abbreviation of it is what? M, small letter M. The next one is what? Mass. Standard unit for mass is what? Kilogram. And abbreviation of it is what? Kg. Time. Unit of time is what? Seconds. That's the standard unit. Abbreviation of it is what? S. Small letter S. While we have the electric current is a fundamental unit. Fundamental quantity. So the unit of it, we use the name ampere. Because this is the name of the scientist that gave us illustration for electric current. We use the name ampere, and abbreviation of it is what? A, capital letter A. Temperature, fundamental quantity. We use the units, the name for the units. We use the name Kelvin, capital letter what? K. Amount of substance, mole. Abbreviation of it is what? MOL, mole. So these are what? Fundamental what? Quantities and what? Units. Very important so long the subject, physics, is concerned. Okay? All right, ladies and gentlemen, what I have on the board is what? Derived quantities and units. Remember I told you guys that these quantities and units, they have what? Two branches, the fundamental and the word derived. So we have listed some of the word fundamental. What I have on the board right now is what? Derived quantities and units. From the word derive, it means that it is obtained. All these what? Quantities and units, they are being what? Obtained. Now, derived quantities, we are talking about what? Quantities that are obtained from the fundamental quantities. The fundamental quantities are the basic quantities. They are independent on their own. While the derived quantities, they are obtained from they depend on the fundamental what? Quantity. Likewise, the units. The units, they also do what? They are being what? Obtained also from the fundamental what? Units. So this is just a list, a few of them. There are many. In fact, there are much more than they were the fundamental. So the first one on our list here is what? Area. Now area is what? Length times what? Breadth. If we expand this, we have what? Length times what? Breadth. Or length times length, as the case may be. So length is being measured. Length is from what? Fundamental what? Quantity. The same thing with breadth. Is the same thing with breadth. Breadth is also what? A length. So they are being what? From the what? Fundamental what? Quantity. You can see how they are also referring to the fundamental quantity. Now the unit for area should be, if length is measured in what? Meter, and breadth is also measured in what? Meter. That's meter times meter will be what? Meter square. So the unit for what? Area is what? Meter square. This is the what? The abbreviation of it. Right here, volume. Volume is what? Length times breadth times height. The length is measured in meter, the breadth is measured in meter, the height is measured in what? Meter. So therefore, the unit, the standard unit for what? Volume is what? Meter cube. So anytime we are calculating for volume in physics, we must make sure that our unit is in what? Meter cube. Density. Density is what? Mass over what? Volume. Now, mass is what? The standard unit for mass is what? Kilogram. While volume is here, meter what? Cube. So therefore, it's going to be what? Kilogram per meter what? Cube. This is the what? The unit for what? Density. You can see that they are being what? Obtained just by a simple mathematical combination of the what? Fundamental quantity. So what I have here is what? Velocity. Velocity is what? Displacement over time. What is displacement? Displacement is what? Extent of space. Extent of what? Space. That is also, that also means what? Length. Displacement is extent of space in a specified direction. That is what? Length. And length is being measured in what? Meter. That is what? Meter per seconds. Time is in what? Seconds. So the unit for velocity is what? Meter per seconds. So we have what? Acceleration. Acceleration is what? Change in velocity over time. Velocity, as we all know, that we have here is what? Meter per seconds. Meter per seconds over what? Time. Time is also what? Seconds. So it's what? Meter per seconds what? Square. So this is the unit for what? Acceleration. While the last but not the least, the last one I have right here is what? Force. Force is what? Mass times what? Acceleration. We all know that from fundamental quantity, mass is calculated, is mean the unit of mass is what? Kilogram. While acceleration, we have acceleration here as what? Meter per second square. So therefore, the unit for what? Force should be kilogram meter per second what? Square. This one is in what? Kilogram. This one is in what? Meter per second what? Square. So the unit for force is what? Kilogram meter per second what? Square. Or we use the name Newton for what? Force. Newton. Remember Sir Isaac Newton gave us an illustration for this quantity, force. So the standard unit for force is what? Newton. Capital letter what? N. That brings us to the end of this what? Episode. Like, comment, and share. And don't fail to subscribe to my YouTube channel. Thank you, and God bless you. Till we meet again.